So let's get down to brass tacks here. What are large language models, how do they work, and how is my rule-based system different? The fundamental difference between the two is that one learns by example, and the other learns by rules. Many psychological studies indicate, at least among humans, that while examples remain important, rule learning is more efficient than exposure to examples. Large language models are models that attempt to simulate the human brain's ability to produce natural language. They're trained with self-supervised machine learning on vast amounts of digital text. They mimic reasoning, or rather appear to reason by pattern matching and statistical inference on their training data. That's hardly a substitute for simulating understanding or true abstract reasoning capabilities like humans. In consequence, they inherit inaccuracies, biases, and outright falsehoods present in the data that they're trained on. The reasoning they mimic is fragile and degrades significantly with increasing problem complexity. They often fail to identify causal relationships and refuse to abstain from answering unanswerable questions. They have a total reliance on memorization, which is learning by example. My system is the exact opposite. It's not trained on anything. Every aspect of its ability to analyze sentences is based on rules. These rules not only identify the part of speech and definitions that apply to each word based on context, but also build a structural diagram of the sentence to show each word's grammatical relationship to every other. That degree of precision lends itself to a means to exercise abstract reasoning to individual statements or questions. It does so in a way that would maintain that reasoning no matter how large or complex a problem is. Large language models have black box problems. That's when they present misleading information as credible. The neural network architecture it generates from the vast amounts of data they're trained with becomes so deep and complex it's practically impossible to trace the internal decision-making processes that generated that particular output, explain why the large language model produced it, and correct it. My system, again, is the exact opposite. It provides complete transparency so that any problems it does encounter can be corrected easily by simply improving and enhancing the rules, and furthermore refining those rules for even greater sentence analysis accuracy. Large language models presume to know the meaning of truly ambiguous sentences and don't bother to ask the user for clarification, leading to obvious misunderstandings. They struggle to recognize when a question is unanswerable and will often hallucinate an answer rather than abstain, even after undergoing fine-tuning of their reasoning. The lack of such clarification has advocates to anthropomorphize large language models, or unjustifiably attribute human-like qualities to them, further leading to misconceptions of their true capabilities. My system makes no presumptions. In addition to the example I have provided in the first video, it takes a sentence like, "The man threw his daughter a ball," and understands it in two ways. Either he physically threw a spherical object to her, or arranged a formal dance for her. Either way, it asks. And it has to ask, because how can anyone expect a system to be better at resolving the ambiguity than the human beings that built it? Large language models often succeed at problems similar to ones on their training data, but fail at those requiring deep reasoning. They have no grounded knowledge or a real-world understanding of the concepts they possess, or a true understanding of the underlying logic of the task to which they're assigned. Instead, they focus on superficial similarities, statistical inference, and memorized patterns, manipulating numerical representations of concepts. They struggle to generalize their knowledge to new situations or novel variations of problems, especially those that deviate from their training examples. What reasoning large language models only appear to perform degrades sharply as problem complexity increases. They fail to scale consistently even when the underlying problem-solving strategy remains the same. And while understanding can never be duplicated but only simulated in a machine, my system possesses a vocabulary in which all words and phrases are assigned concepts within a framework called an ontology to establish relationships between them. This is one of the things that my system uses with its rules to make its level of sentence analysis possible. As implied by their name, large language models require massive storage of data in servers. My system runs on a single PC. I'm not entirely against LLMs. I'm simply pointing out limitations that advocates often conveniently ignore. And while I haven't actively sought collaboration with anyone to produce a hybrid system to achieve the advantages of both, I'm not against the idea either. Please bear in mind that building this technology took a massive amount of time, effort, experimentation, and creative programming. I've gone through countless failures before finally hitting on a series of robust methods that run with stability on a growing battery of test sentences. Software development may be partly an engineering discipline, but it also demands scientific investigation based on objective evidence instead of personal bias or opinion. Based on extensive experimentation and testing, the results are dependable, testable, and repeatable. In that, the operation of any software, including my own, is not a matter of belief or opinion. Either it works the way I claim, or it doesn't. And if I still have your attention or interest and would like to know how it works, click on the link below.